So as soon as we're done, it'll be live. So everything you say we'll be able to hear, and you'll be able to hear me as well. And we'll get started in just a second. I'm going to share my screen now.
Okay.
All right, so lots of good questions today. Let's see if we can run through them. I'm going to do these kind of quick, so you just stop me or say something if you're having a hard time, but we can also come back at the end and you can ask questions about the things that I did. But because you've got lots of good questions, I'm going to go kind of quickly through this. Is that okay?
Yeah.
And like I said, it's recorded, so you can always go back and watch the recording on YouTube. It's being streamed live right now. Anyone who's on my channel watching live, hello. I'm here with Kaylee, and we're talking about pre-calculus. And if you have questions, you can sign up for tutoring on 204tutor.com and ask your own questions. All right, so complete the square to write the following function in vertex form. So completing the square means basically we want to turn this equation into the form y equals a times x minus h squared plus k. All right, and so we're trying to turn this into that form. This is called standard form. And so to complete the square, the first step is to factor out whatever's in front of the x squared. So I'm factoring a 3 out of x squared and out of 24. So what's 24x divided by 3?
7 or 8.
Good. 8x. Good. I'll ask you, but then I'll just do it if you don't answer it quick enough. So no big deal. And notice I didn't do it to the 8. I left the 8 on the outside.
Okay.
Okay. Because I'm choosing only to factor that out. Now what I'm going to do is add twice. I'm going to take half of what is in front of the x term, which is 4, and I'm just going to square it. And I'm going to add it here. And I'm going to subtract it. Because I've added it here, I have to kind of undo that. So I'm going to subtract. I like to put a box around it so you can see that I'm adding it there and I'm subtracting it here. The only problem is I'm not really only adding 16 to the equation, right? Because there's a 3 on the outside. I'm actually adding 3 times 16, which is 48. So what I have to subtract is 48. Can you see how I've added 48 and I've also subtracted 48 from the same side of the equation?
Yes.
Okay, so why would I do that, you ask? Well, now what happens is this factors into a perfect square. It factors into x plus 4 times x plus 4, which could be written as x plus 4 squared. That makes sense?
Yeah.
And then over here, I have -8 minus 48, which is -56. And so look what I have. I've rewritten this equation that was in standard form up here. I've rewritten it into this form called vertex form. So there's my vertex form equation. So the vertex I can see is -4. I take the opposite of what's inside here. It's h comma k is your vertex. So I take the opposite of what's in with the x, and then I take what's on the outside. So my vertex is -4 comma -56. There's my vertex form right there. The x-intercepts. Now this is nice for finding x-intercepts as well. I'll do that. I don't have a ton of room, but I'll try to do it right here. So to find x-intercepts, I set y equal to 0. And you can kind of do that in your head. I'm first going to add 56 to the other side. So I'm going to write 56. And then I'm going to divide both sides by 3, because that 56 would be gone, right? So divide by 3. Are you following what I'm doing?
Yeah.
So divide by 3. That's not a pretty number, so I'll just leave it like that. Then I'm going to take the square root to get rid of the squared. I'm going to take the square root of both sides. And don't forget to put a plus or minus sign in front of that when you do it. By the way, I'm gonna write this over here so I have some room. So I'm going to take the square root of both sides, and don't forget the plus or minus sign. And then I'm going to subtract 4 to get rid of what you'd have left, the +4. So I'm going to subtract 4. So there are my two intercepts. See, I've got the plus or minus sign here. That means one of them is the plus, one of them is the minus. And if they want you to simplify this more, you can, but I don't know if they do for you in this case.
No, that's how he's having us leave it.
Okay, so that's that. Now the Y-intercepts, the Y-intercept actually, it's easier to use the original standard form for the Y-intercept, because remember how you find the Y-intercept? You plug 0 in for X.
Uh-huh.
So those both cancel and your Y-intercept is just -8. So 0, -8 is your Y-intercept. Okay. The domain, so let's go ahead and, I mean, it's kind of hard to graph this because it's so far. The vertex is -4, -56. So -4, -56, let's pretend like -4 is right here and -56 is way down here. Your intercepts are, notice where they are, they're plus or minus the square root of 56 over 3. So let's see, what's 56 thirds? What I like to do is take 56 thirds, 56 divided by 3. So that's 18 and 2/3.
Mm-hmm.
So the square root of 18, well, think of the perfect squares around 18. What are they? I don't need an exact number. This is roughly, this is roughly right here. Do this in blue. This is roughly 18. Well, it is 18 and 2/3. So what's what are the perfect squares? What two perfect squares is 18 and 2/3 between?
16 and
Good job, 25. It's between 16 and 25, and the square root of 16 is 4, and the square root of 25 is 5. So it's going to be a little bit more than 4, right? So it's a little bit more than 4, and look where I'm going. Here's my -4 right here. And so this is my axis of symmetry, goes through the x-axis. And so it's going to be a little bit more than 4, so it's going to be just on the right side of the y-axis, and it's going to be just on the left side of -8 over here.
Okay.
And so I can just draw my graph and kind of eyeball it. And well, where's my y-intercept? -8. So -8 is down here somewhere. So that checks out, doesn't it? You see how that makes sense?
Yeah.
All my points make sense in here. Okay, so the domain, I drew that first because that is easier to find the domain and range. Remember the domain, what I teach people is you take a vertical line and you just scan it. And you ask yourself, when is it not, from left to right you scan, when is this not going to touch the blue graph? Is it ever not going to touch it?
No, it would be all reals.
Correct, it'll be all real numbers, very good. So the domain is all real numbers, which we write like this. And how about the range? Do a vertical line or a horizontal line scan from bottom to top. When is it going to touch it? It's not touching it until where?
It at the square root of -56 and 3.
Nope, that's these points here.
Oh, right.
That's your y coordinate of your vertex, right?
Yeah.
So it's -56. So it touches at -56, and then it touches it everywhere above that. That makes sense?
Yep.
And can you tell where the min is?
That I need help with.
So the min, look at your graph. Where's the minimum? What's the smallest point on this blue graph?
-56.
Mm-hmm. And so what you say is it's got a minimum of -56 at x equals -4. So your vertex tells you that minimum.
Okay.
Where is the increasing interval? Well, it's increasing to the right of the vertex, right? From left to right, it's going up if you're to the right of the vertex. So that interval would be from -56. I'm sorry, I did that wrong. From -4, you always write it in terms of x. You always write the interval, increasing and decreasing interval, in terms of the x-axis. So what for what x values is it increasing? From -4, from right there all the way to infinity. All of those x values are increasing. If you jumped on that graph, you would see those x values As the X value gets bigger, the Y value gets bigger. Does that make sense?
Yep.
So it's to infinity. And then where is it decreasing?
It would be then negative infinity to -4.
Perfect. You got it. And always use open intervals for that. Okay. Good.
Yeah.
All right. Next page. Next question. It says complete the square to write the following in vertex. So this is the same thing. So let's just do it. I'll do it a little bit quicker this time. Okay. So the first thing I'm going to do is factor out a 4 from both of those X terms. So that's going to be plus 2X, and I'm going to leave a space here, and then I'm going to leave the 49 on the outside. Now I'm going to add half of 2. So take half of 2 and square it, which is going to be 1. And I'm adding it here, and I'm subtracting it on the outside. Well, what am I going to subtract?
It would be 1 squared, correct? Or no, sorry. It'd be 4.
Very good. It's 4 times 1. Exactly. It's 4 times 1. Good job. So now let's factor it. So 4 times X plus 1 squared plus 45. So there's my function in vertex form. So let's see, they want us to graph it. Yeah, sketch a graph. Said it might be helpful to sketch a graph. Well, let's go ahead and do it. So the vertex, so there's your vertex form right there. The vertex is, you tell me what it is.
It'd be -145.
Perfect. Good job. So -145 is way up here somewhere. There's -145. And is it opening up or down?
Opening up.
Because it's a positive leading coefficient, right? So it's opening up. So hey, what do we know about the X-intercepts? Am I going to have any X-intercepts?
No.
I'm not. So I can say none. I don't even have to mess with it. Now you could try. If you tried, what would happen when you subtract 45 over, and then you divide by 4, and then you try to take the square root? What are you going to have over here? You're going to have a -45 fourths.
Oh, so it would be a imaginary number.
Yeah, and that's the reason that you don't have any. But see, if you graph it first, you'll recognize that, and you don't have to waste your time trying to find it.
Okay.
That makes sense?
Yeah.
How about the Y-intercept?
You would put 0 into the X's.
For which one? The top one or the completed square?
The completed square.
You can, but it would be harder. Why not just put it in there?
Okay.
Gone, right? That's your constant is always your Y-intercept when you have standard form. So it's easier to use that since you have it. You might as well use the one that's easier.
Okay.
Because you have to do some work if you plug it into here. Got it? What's the domain?
All reals.
Good. What's the range?
It'd be
Remember horizontal lines scans? No. Yes. And where is it touching it? We're looking at, since we're talking
49.
about range, 45.
45.
Right? 49 is the Y-intercept. 45, it's always, the range is always based upon the Y coordinate of your vertex. Okay? So it's from 45 inclusive, so put a bracket like that, to infinity. See, your Y-intercept was 49, it's right there. That's 0, 49. That was your Y-intercept, but it actually started at 45, not at 49.
Okay.
The lowest Y value is 45. Does that make sense?
Yes.
All right, do you have a min or a max?
Would it be you'd have a min, correct?
A min of what?
Of 45.
Good. 45 at X equals what?
-1.
Good. What's the increasing interval?
It is from -1 infinity,
Perfect. And what's the decreasing?
negative infinity to -1.
Perfect. You got it. Good job. Well done. You seem to understand that. All right, next question. The Golden Gate Bridge has a span between its two main towers of that much. So let's see, how's a bridge span? What's it do?
Sorry, can you repeat that?
Yeah, what is this? What is the Golden Gate? What does that mean? The span is 45. Is it like this? 1280 meters?
Yes.
The towers extend 145 meters above the road surface. So there's your road. This is 152 meters. The cables are parabolic in shape and are suspended from the top of the towers and touch the road at the center of the bridge. All right, so here's the center of the bridge, which is how far from each side? This distance would be half of 1280, right?
Yeah.
So this distance would be what, 640?
Mm-hmm.
Okay, just because we probably are going to need that at some point. And are suspended from the top of the towers and touch the road surface at the center of the bridge. Okay, so here's there, and it said that they're parabolic, so we know it follows a parabola. So it's going to do this, and it's a parabola. That wasn't very good. Let me try that again. My wife's the artist, not me. All right, close enough. Okay, you get the point. So let's call this point right here. Let's call that point just for ease in this. Let's make it. We're going to make a XY plane.
Okay.
And let's call that point 0, 0. No. Yeah, let's call that 0, 0.
Okay.
I'm sorry, it's not 0, 0. Yeah, it is 0, 0, right? We're calling that the origin.
Okay.
So this point up here would be what?
I can't see your cursor.
Oh, wait, why? Yeah, you're right. Why can't you see it? Oh, you can't see it?
I just saw you circle it.
Okay,
So
sorry about that. What would
no,
this
you're fine.
point be up here?
That point would be 640 and then comma 152.
Close. It wouldn't be positive 640. It'd be
negative 640.
Mm-hmm. And the one on the right would be positive
640 and then
152. And this point down here would be 0, 0.
Okay.
Okay. Let's see. It says draw and label diagram of the points and write the function. Find the height of the cables 400 meters from the center. So they want to know what the height is 400 meters from the center. So 400 meters away, they want to know what this height is.
Okay.
When this distance is 400. So we have to write an equation, and then we're going to plug that in 400 for X. So how do we write an equation? I'm trying to think if there's an easier way to do this. Have you done problems like this before, and do you use systems of equations?
I have done problems like this before, and
I feel like that. I mean, that's how I do it. But
we've kind of put it into a
system
Vertex form. It looks like.
But how did you put it in Vertex form? Oh, okay. Let's see if we can do this. Let's see if we can go y equals a times x minus h squared plus k. Oh, yeah, we can do this. It's still a system of equations, but what's h and k? We already know h and k, right?
Yes.
H and k are both 0. So we have y equals a x squared. And so we're going to take both of these points and plug them in for X and Y.
Okay.
Actually, yeah, we don't even need, do we need both? No, I think it'll work with just one of them. We're going to solve for A by plugging in. Yeah, that's what we're going to do. So we're going to plug in this X is 640, right?
Mm-hmm.
And Y is 152. And so we can solve for A by doing that. So 640 squared and so it's A, basically A is going to equal 152 divided by 640 squared. That's what A will equal.
Okay.
So let's take our calculator out and punch that in. I would do some fancy schmancy stuff maybe, but let's just use the calculator again for the sake of time. So 640 squared. So it's 0.000371.
Okay.
You understand how you can do that using
Yeah.
your calculator? So 0.00, let's see, 3 zeros and then 371. 3 zeros and 371. A equals 0.000371. So now I can plug that back into this equation up here, this red equation. Now that I know what A is, I can plug that in. I'm kind of running out of space. I'll do it on the left side here. Y equals 0.000371 X squared. So to find out the height, 400 meters away from the center of the bridge, we plug in 400 for X. And solve for Y. So plug 400 in, 400 squared, and then multiply that by 0.000371, and you get 59.36.
Okay.
Does that seem right? Do you have the answer key?
I do. What was
59.36? That sound right?
It's sorry, the way he has yes, that's right.
All right. So you see how we did that?
Yes.
So we didn't actually have to use a system of equations because we put the the origin of my XY plane right at the center point. So that made that problem easier. There's other ways you could have done this, but that works. Does that seem about how your teacher did it too?
I actually missed the date of class that he went over this, so.
Got it. Yeah, I'm pretty sure that's the most efficient way of doing that problem. All right, next up. A parabolic arc has a span of 120 feet and a maximum height of 37. Okay, what kind of arc?
Parabolic. So
is it gonna be upside down arc? Is that what they mean by arc? I guess they do. So here's my arc, and it has a span of 120 feet, and it has a max height of 37 feet. It says draw a diagram, label any key points, and write an equation of a parabola that models the arc. So same kind of deal. We're going to go ahead and draw in our XY plane. Now in this case, I think it would make more sense to make this point the origin. I'm sorry, not the origin. This point down here, it would make more sense to make that point
0, 0.
0, 0, right?
Okay.
That makes sense. So what's this point over here going to be?
That would be whatever half of 120 is. 0.
60. 0, comma 60. And this one over here is going to be what?
Oh,
I'm sorry. You're right. I did it wrong. I made it the X instead of the Y. Yeah, you're right. You said it correctly. 60, comma 0 and negative 60, comma 0. And what's this point up here?
37 or 0, comma 37.
Perfect. You got it. 0, 37. Okay, so there are my points. Now it says find the height, and it says write the equation of the parabola that models the arc. So we're going to have to write this in y equals a times x minus h squared plus k form again. What's h and k?
H is
remember, h is your y coordinate of your vertex. K is your, I'm sorry, h is the x coordinate of your vertex. K is the y coordinate.
Okay.
So 0 goes here, 37 goes here. So my equation is y equals a times x squared plus 37.
Okay.
And how do I solve for a?
You would plug in an x and y point.
Which one?
Would 0, 0 work?
Well, that's not one of the points.
Oh, correct.
Right.
60, 0.
Good. 60, 0. So 60 goes here, 0 goes here, and we solve for a. So subtract 37 from both sides. 60 squared is 3,600 times a. And so a equals negative 37 over 3,600. So now let's rewrite our equation. I'll write it up here in black. Y equals, the a coordinate is negative 37 over 3,600. And then x minus h, which is 0, right? So just x squared plus 37. Got it?
Yeah.
And for that one, it actually makes more sense just to leave it as a fraction instead of like punching into your calculator. Now it says find the height of the arch 48 feet from the center. So I'm going 48 feet. So this distance is 48, which means they want to know what the height is. So what's this height right here? 48 comma what? So what do I do? What is the 48? Is that an X or a Y value? If it's 48 feet from
that'd be an X value.
Good. So I'm going to plug 48 in here. Plug in 48 and then solve it. So negative 37 over 3,600 times 48 squared plus 37. Punch that into your calculator. So negative 37 divided by, actually, hold on, let me do 48 squared first. 48 squared, hit enter. And then what were my other?
It was negative 37 divided by 3,600. And then
so I would multiply that by
the
negative 37. Then I would divide that by 3,600.
And then plus 37.
Then add 37 exactly. So 13.32 is my height. 13.32. 13.32 feet. Unless I punch something in wrong there. Seem about right?
Yeah.
Awesome. All right, let's just do these ones real quick. Find the axis of the vertex. Oh, you're good with this, right?
Yeah.
Vertex is going to be negative 3 comma 4 axis of symmetry is always a vertical line. So it's x equals whatever the x coordinate is of your vertex. So x equals -3. The x-intercepts, you would solve this equation, plug in 0 and solve it. This is what I did kind of in my head before. Let's do it on paper this time. Subtract 4 from both sides. Multiply both sides by -9 to get rid of that. So that would give you, what, 36? 36 equals x plus 3 squared. Take the square root of both sides. So that's plus or minus 6. And now subtract 3. So x equals -3 plus or minus 6. -3 plus 6 is +3. -3 minus 6 is -9. So 3 and -9. And your y-intercept, plug 0 in for x. When I plug 0 in for x, I get 3 squared. Right here, I get 3 squared, which is 9. 9 and 1/9 cancel, it becomes -1. -1 plus 4 is?
Yeah.
Sorry, I did it really quick.
Mm.
All right. I am out of time for these last two.
Okay.
I knew it was going to be tight because there were some lots of good questions, but hopefully that helped. Try those ones and maybe swing back by at about 9 o'clock tonight. I'll be done. If you want to swing in right before 9, if you need help with those last two, give them a try on your own though. Okay.
Okay.
Awesome.
Thank you.
Hey, this will be on YouTube, on my YouTube channel.